Hi, this is Judy Greenwald, the Deputy Director for Climate, Environment, and Energy Efficiency at the U.S. Department of Energy. I am also the Senior Advisor on Climate Change to the Secretary. I wanted to welcome everyone to our third and final webinar of the Accelerating Energy Productivity Series. Today's webinar features speakers from the transportation and water sectors. It's a pleasure to be here virtually with all of you today. I'd like to extend a special thank you to our colleagues and partners at the Alliance to Save Energy and the Council on Competitiveness. We're here today to talk about leveraging the great work of the Accelerate Energy Productivity 2030 initiative to provide valuable input for the Quadrennial Energy Review, or the QER. The QER was initiated on January 9th, 2014 via a presidential memorandum. The purpose of the administration-wide QER is to translate federal policy goals into a set of analytically based integrated actions, such as proposed executive orders, legislation, or budgets over a 4-year planning horizon. Unlike other federal quadrennial review processes, where analysis is done every 4 years, the QER is being conducted in multiple installments to allow for more granular analysis of key energy subsectors. Just a little over a year ago, on April 21st, 2015, the QER Task Force released the first installment of the QER, which we refer to as QER 1.1, on transmission, storage, and distribution of liquid fuels, natural gas, and electricity. The second installment of the QER, or as we call it, QER 1.2, is focusing on electricity from generation to end use. That's what we're here to talk about today in the context of energy productivity, specifically within the transportation and water sectors. To develop a set of findings and policy recommendations in QER 1.2, we need your perspective, expertise, and input. In addition, we welcome and encourage any listeners or participants who would like to formally submit input into the QER process to do so. All you have to do is go to www.energy.gov/QER and follow the stakeholder engagement page hyperlink to access and submit a public comments form. Thank you in advance for your thoughtful input today, and we look forward to hearing from you. So now I'm going to hand it over to Mike Bernstein, Senior Policy Director at the Council on Competitiveness.
Thank you, Judy. Good afternoon, and I'd like to personally welcome everyone to the webinar. I hope you're able to join us for the first 2 webinars on accelerating energy productivity through building technologies and financing and smart grids, smart manufacturing. If not by way of introduction, I have the honor and privilege of representing the Council on Competitiveness on behalf of Deborah Wynn-Smith, our President and CEO. The Council is a 30-year-old nonpartisan leadership organization of CEOs, university presidents, labor leaders, and national laboratory directors committed to advancing U.S. competitiveness in the global economy and a rising standard of living for all Americans. We accomplish this by identifying emerging forces transforming the overall productivity potential of the economy. As such, our focus over the past 3 decades is centered around critical drivers like innovation, sustainability, resiliency, and the power of people. Over 15 years ago, the Council launched a series of foundational efforts, many with the Department of Energy, making the business and research case that energy is everything. In that time, it seems many other organizations have come to the same conclusion that we and the Alliance to Save Energy did so many years ago. Energy, and the ability to apply it efficiently and with purpose, is the first step on the path to prosperity for the American people. Improving the productivity of energy in our transportation system means moving people, goods, and services around the country at a lower cost, creating more opportunities for entrepreneurs and large corporations alike to pursue ventures that they would not have been able to before, leading to new growth and jobs with less per capita environmental impact. Similarly, the same energy productivity reduces water consumption and pollution, making Americans healthier and safer. America is more competitive when people want to work and invest here, which is a product of when we have clean and reliable transportation and natural resources. If we pull this thread, it means energy productivity is a critical component driving our competitiveness. The opportunities ahead for our nation are unprecedented if we are able to improve energy productivity. More broadly, efficiently and effectively controlling our energy needs improves our energy security and independence and reduces the cost of innovation. Though this is the last webinar in our series, I urge you to stay engaged with us through social media, signing up for our monthly newsletter, or picking up the phone and contacting us directly, and for sharing what you've learned from any component of the webinar series with your own colleagues and networks. On behalf of Deborah, our president who couldn't be with us today, and the entire council, quickly I want to thank Kateri Callahan of the Alliance to Save Energy and her great team for their partnership. I'm proud of the work the Council on Competitiveness and the Alliance to Save Energy teams have undertaken together on many fronts. And I'd also like to thank Judy Greenwald and their team at EPSA. Over the course of our 30-year history across Democratic and Republican administrations, the Council has been honored and privileged to work with senior leadership from the Department of Energy. I want to give you all on the webinar a heartfelt thank you for joining us today. And now I'll hand it over to Kateri Callahan, the President of the Alliance to Save Energy.
Thanks, Mike. I appreciate that. And let me start by thanking you back, and also Judy Greenwald and the great team at EPSA for the partnership around Accelerate Energy Productivity 2030, the business of our call. As Mike said, we're in the third of a series of webinars that have really two goals. The first of which Judy talked about, which is to inform the QER 1.2 that's being developed. But the second of which is to explore the key wedges, if you will, or areas, and in this case we've got two, water and transportation, where we in our partnership through Accelerate Energy Productivity 2030 have devised an implementation pathway or a roadmap, if you will, of how we get to doubling energy productivity in the United States. And when we talk about doubling energy productivity, what we mean by that is getting twice as much GDP from each unit of energy consumed. Or as the President said to all Americans in his 2012 State of the Union address, the goal for our country is to cut wasted energy use in half by 2030. So why do we want to do that? What do we get out of it? I think one of the things that we wanted to talk about real quickly, just to frame up the discussion here, is that doubling energy productivity means for our country some very important things. As I said, 2 times the economic output for each unit of energy consumed. And by doing more with less, we save a lot of money, $327 billion economy-wide, and the largest portion of that savings actually comes from the transportation sector, and we'll be talking more about that in a minute. Saving energy and driving efficiency throughout the economy also is a big jobs creator. The economic analysis that we had undertaken as the Alliance to Save Energy indicated that we will create 1.3 million jobs. We will lower imports to get us to the holy grail that so many policymakers talk about of being energy independent, because our net imported energy would represent only 7% of what we would be consuming. And while the figure isn't up here, what it means in terms of savings of CO2 are ginormous. It's 2.5 billion tons of CO2 annually we would be saving if we're able to cut our energy waste in half. So really, really important achievements for our country. And what's it going to take to get there? Well, again, today we're going to talk a little bit about how we can use the water sector and the transportation sector and drive efficiencies there. But one of the things we really want out of all of you on the phone today is twofold. One, we'd like you to join us in this quest. We've got a slide up here that shows you that we have 136 companies, states, cities, NGOs, universities who have already committed to help us drive toward the goal of doubling energy productivity in the U.S. And we would very much like you to join us. You can go to our website at energy2030.org and figure out what that means to endorse our goal and join with us. But we want you to continue to be a part of this effort beyond today's webinar. The other thing that we need for you to do today is to submit questions and input. As Judy said, the input is going to inform the QER, and it also is going to help all of us as we begin to share best practices, talk about challenges and opportunities as we drive toward the goal of doubling energy productivity, to figure out how to do that most efficiently, pun intended. So with that, let me turn now to our two great presenters that we have here today. I'm going to introduce them both now, but the way that we're going to run the rest of the the webinar, is that we'll hear from our first speaker, then we'll pause, and we should have about 15 minutes where we'll have a virtual conversation with you on the phone. So as questions occur to you when the presentation is being made, please submit those, and Judy Greenwald is going to lead us through a Q&A section with the first speaker. Then we'll move right in from that into the second presentation on water, and then again, as soon as that presentation is done, follow up with another 15 minutes of Q&A. So we're going to make this as interactive as possible and as fun, and we are going to hope that we come out of it with a lot of input from all of you on the phone. So I hope you'll stay with us through both presentations and both Q&A periods. With that, let me introduce our speakers and thank them both for giving so freely of their time to be with us today. We're going to hear first from Kathy Kinsey, who's a Senior Policy Advisor with NASSCOM, which is the Northeast States for Coordinated Air Use Management. Right now, she's focusing on electric vehicle initiatives and implementation of the Multi-State Zero Emission Vehicle Action Plan, and she's going to talk to us about that. She has had a number of senior leadership positions prior to coming to NASSCOM, and most recently she was Deputy Secretary for Regulatory Programs and Operations in my now home state of Maryland at the Maryland Department of the Environment. She has 2 decades of experience in a broad range of environmental permit enforcement, regulatory policy, and operational issues. So again, we're delighted to have her expertise with us today. Second, we will hear from Michael McDonald, who's a senior engineer at American Water. Michael has been at American Water for 5 years. Before that time, he was in consulting. He right now is in his job as senior engineer for American Water, is facilitating American Water's corporate-wide energy efficiency program. He has a MS degree in civil and environmental engineering, and he also is a registered professional engineer from the state of Massachusetts, or I should say the Commonwealth of Massachusetts. So again, thanks to both of you, and Kathy, we will start with you and your presentation.
Great, thanks, Kateri, for that nice introduction. Can everyone hear me?
We've got you loud and clear.
Great, always want to make sure. So first I just want to thank DOE and the Council and the Alliance for the opportunity to participate in this webinar today. I hope that folks find it helpful, valuable, and informative. So I wanted to just say a word about my organization, NASSCOM, the Northeast States for Coordinated Air Use Management. NASSCOM is an association of the air pollution agencies of the 6 New England states and New Jersey and New York. And we serve as the technical advisor to our member states on a wide range of air quality, climate matters, and as the facilitator for an 8-state collaborative effort to accelerate electrification of the light-duty vehicle transportation sector in our states, which is the focus of what I'm going to talk about today. So, David, can you advance the slide, please? Thanks. So this collaborative effort has its genesis in a memorandum of understanding that was signed back in October of 2013 by the governors of California and 7 other states that have adopted California's ZEV mandate. And so for those of you who may not be familiar with the ZEV regulation, the Zero Emission Vehicle, the ZEV regulation requires automakers to place increasingly larger numbers of zero emission vehicles each year in states that have adopted the regulation. And I'll be talking a little bit more about that later. So under the Memorandum of Understanding, the governor set a collective target of having 3.3 million zero-emission vehicles on our roads by 2025. And under the MOU, they further committed to establish a multi-state zero-emission vehicle task force to develop and then subsequently implement comprehensive zero-emission vehicle action plan that is designed to achieve the state's electrification goal. So the task force completed an action plan in May of 2014. It's a 30-some page document which identifies initiatives and other measures to address a full range of barriers to widespread adoption of electric vehicles. And for those of you who are interested in the details, we posted the action plan on the NASSCOM website, so you can look at it there. Next slide, please. So the need for this collaborative effort is, I think, well illustrated by this slide, which depicts the Section 177 state CO2 emissions. So just for purposes of clarity here, there are a total of 9 states that have adopted the California ZEV program. We commonly refer to ourselves as the Section 177 states, which is a reference to the Clean Air Act provision that authorizes other states to adopt the California vehicle emission standards in lieu of the federal standard. So the ZEV MOU states are a subset of the Section 177 states. So Maine and New Jersey have also adopted the ZEV regulation, but they are not signatories to the MOU. So all of the MOU states, ZEV MOU states, have very ambitious 2050 greenhouse gas emission reduction goals that are comparable to California's. And you can see from this slide that the transportation sector has now completely eclipsed the power sector as the single largest source of CO2 emissions. Now they're roughly 50% of our collective statewide CO2 emissions. So clearly we have a pretty big challenge ahead of us. Next slide, please. So our states believe that electrification is really the key to reducing transportation sector greenhouse gas emissions and meeting long-term energy goals. And electric vehicles have a big advantage over conventionally fueled vehicles. They're significantly more energy efficient. And you can improve on the energy efficiency of gasoline-powered vehicles by doing things like reducing vehicle weight, improving maintenance practices, paying more attention to how you drive, improving systems used in the vehicles. But there is only so much you can do to improve on efficiency with conventionally fueled vehicles. By their nature, however, electric vehicles on average are at least 2/3 more energy efficient than their comparable gas-powered cars. So this is, I think, well illustrated by this comparison on the right-hand side of the screen that you're looking at, which compares the 2015 Volkswagen Golf and its electric counterpart, the e-Golf. So you can see that the e-Golf travels more than 100 miles on what is the equivalent to 1 gallon of gasoline. And, you know, the fact is that, you know, we have all of our states and the federal government are doing a lot of work on land use, smart growth initiatives, those sorts of planning strategies, and they're very important, obviously, to reduce transportation sector greenhouse gases. But the fact is that no amount of smart growth, demand-side management, transit-oriented development, or even expanded mass transit is going to give us the kind of greenhouse gas reductions on the scale that we need in the time frame we need to avoid the worst impacts of climate change. So in the view of our states, electrification of the transportation sector, you know, is the critical strategy, especially because as the grid gets greener over time, as it certainly will do, transportation emissions continue to go down. Next slide, please. So I mentioned earlier that the ZEV regulation requires increasing sales of ZEVs over time as a percentage of each manufacturer's new car sales volume. So this is what the sales trajectory looks like through 2025. You can see that ZEV sales requirements really start ramping up in earnest in 2018 with a ZEV requirement of 4.5% of each manufacturer's sales volume. up to 22% in 2025. Next slide, please. So this is what the projected vehicle sales look like under a scenario which is really based on production of 84-mile battery electric vehicles, vehicles with an 84-mile electric range, and plug-in electric hybrids with a 15-mile electric range. And that was the current technology when this analysis was done for the ZEV Action Plan several years ago. So the orange wedge that you see here on the screen represents plug-in electric hybrids, and the green wedge, the true zero-emission vehicles, pure battery electric vehicles, and hydrogen fuel cell cars. And the higher the electric range of a vehicle, the fewer the number of cars that are needed to achieve compliance with the ZEV regulation, and that's because longer range cars actually get more credit under the regulation. And so the number of required vehicles ultimately that will be required to comply with the ZEV requirements will change some as the technology advances and the battery range improves. But this is our best guess at this point in time, based on technology to meet the current technology that was in place 2 years ago. So under this scenario, you can see that by 2025, annual sales of nearly 600,000 electric vehicles would be required in the ZEV MOU states. And I'd like to just put some context around that number. At the end of December 2015, just a few short months ago, cumulative sales of electric vehicles in the United States hit the 410,000 mark. So the real challenge ahead of us in the coming decade to meet our goals is consumer acceptance of this technology. So next slide, please. And that's where the ZEV Action Plan comes into play. So the action plan that we completed in May of 2014 addresses 8 primary barriers to widespread consumer adoption of electric vehicle technology, and they range from the need for vehicle purchase incentives to expanding adoption and infrastructure for hydrogen fuel cell vehicles. I'm not going to talk about each of these individually. We just don't have time for that, but I thought that I would talk in a little more detail about several of our highest priorities where we have been focusing in the last couple of years. Next slide, please. So the incremental difference in vehicle purchase price between electric vehicles and conventionally fueled comparable vehicles continues to be one of the biggest barriers to more widespread adoption by mainstream consumers. And when the governor signed the MOU back in 2013, only California and one other ZEV MOU state had established any kind of vehicle purchase incentive programs. So today, a little more than 2 years later, 7 of the 8 ZEV MOU states now offer purchase incentives, either in the form of tax credits, very similar to the federal tax credit that's available, or point-of-sale rebates. And all of the ZEV MOU states are providing funding in some form or another, whether it be through grants, incentive programs, tax incentives, point-of-sale rebates, low-interest loans for charging infrastructure deployment. Next slide, please. So that has been one of our highest priorities, just simply because of the importance of reducing the purchase price of the car. Then the other very high priority for us is infrastructure build out. And so this slide represents where we are today with our build out in the Section 177 states, which again includes New Jersey and Maine, and California, with public and private non-residential charging stations. You can see that since 2011, we've made an awful lot of progress in deployment of public and workplace and other commercial public charging outlets. but we still have a long way to go to have the infrastructure in place on the scale that will be needed to serve, the millions of electric vehicles that we envision on our roads in the next decade.
Kathy, could you just real quickly, can you explain to people what the red and the blue lines are? There's not a key on the slide, so we don't know what we're looking at.
I'm sorry, I've looked at this graph for so long. It's just second nature to me. So the red line is it represents public charging stations, public and private charging stations deployed in California only. And the blue line represents the number of public and private non-residential EV charging outlets that have been installed in all of the Section 177 ZEV states, and that's 9 states. That includes the ZEV MOU states, plus Maine and New Jersey. Does that help?
Very much.
And Kathy, this is Judy. I'm looking at the original slides you submitted, and they did have the legends. So we, on our end, will make sure that when we circulate the slides after the fact that they have the correct legends on them.
Okay, great. Sure, thanks. Sorry. Okay, next slide, please. So the ZEV states are going to continue to work on, the full range of initiatives that we've been working on for years in workplace charging and fleet initiatives and dealership engagement. But we, going forward, there are 3 areas in particular that we have decided definitely require a more focused effort over the next couple of years. The first is utility investment in transportation electrification programs. The second is raising consumer awareness and interest. And the third is dealership engagement. And I'm just going to say a word now about dealership engagement before talking about the other 2. Dealers are the point of contact with consumers who are car buyers. In this country, we have some great dealers. Some are real ZEV champions, and they do a terrific job of marketing these vehicles. There's a dealer in Vermont that our Vermont folks are fond of talking about, who is located in the northwest section of the state in a very rural area, and has managed to sell more than 30 electric vehicles in 1 month, which is just really remarkable, I think. But I think he's probably the exception and not the rule, and many other dealers are just not particularly enthusiastic about the technology. And so they're not as knowledgeable about electric vehicles as they are about conventionally fueled vehicles. It takes longer to sell an electric vehicle sometimes than it does to sell a conventionally fueled vehicle. There are a lot of factors that go into that. So this is really an important area, and the task force has just formed a work group with the National Dealership Association and several of our state dealership associations with state representatives to try to build a better understanding of the challenges, facing dealerships, and explore ways that, we as states can better support dealers. So, this effort is just getting underway. We've had a couple of calls and one very good face-to-face meeting. And so we're really excited about this initiative and hopeful that it will be a really productive effort on our part. So next slide, please. So on utility investment and transportation electrification programs, so, the states and auto manufacturers, the OEMs, have played up to this point and continue to play really a critical role in the current infrastructure build-out in our states. But fact is that both the states and the OEMs have limited resources, to support a charging network on the scale that is going to be needed to service, millions of electric vehicles. So electric utilities are in the infrastructure business. That's what they do. And they are really very well positioned to lead deployment of charging infrastructure in their service territories on a scale that I think neither the private sector nor the states nor the OEMs could do. And so 3 California utilities have recently submitted proposals to the California Public Utility Commission for approval to deploy on a rate-based basis charging infrastructure in their service territories, and to launch as well a robust consumer outreach and education program on the benefits of electrification. So the California Public Utility Commission has approved 2 utility pilot projects for deployment of charging stations and consumer outreach programs. There's a 3rd application pending, and a decision on that is expected in the June timeframe. So we on the East Coast in the ZEV MOU states have been following these California developments with great interest. Next slide, please. Oh. The screen just went dark. No.
We can still see it.
I got it. Nope,
Okay.
I got it. I know my screen just went dark on me. It's fine. I have it back now. Thanks. So, you know, clearly the California utilities have been persuaded that there's a strong business case for utility investment in infrastructure and as well in other transportation electrification programs like fleet electrification and rate design, time of use rates that benefit electric vehicle charging, you know, other consumer outreach and education. You know, electricity load growth has stagnated since 2008, and that trend is one that's expected to continue for some time. EVs put kilowatt hours back on the grid, and they represent a potential significant load growth opportunity for utilities. So increased throughput on the electrical system that's associated with EV charging increases utility revenue and reduces the fixed costs of running the grid. And EVs can help balance energy use by charging during the day when the solar generation is highest, or during night when wind power ramps up and when demand is lowest. So they really can help with basically taking up the slack on the grid. All of these various efficiencies actually put downward pressure on electric rates for all ratepayers, not just ratepayers who drive electric vehicles, but all ratepayers. So transportation electrification is a win-win-win for utilities, for utility customers, and for the environment. So we could do a whole presentation on this subject alone. So I'm not going to say much more about that and just leave it at that. That there are considerable benefits to utilities, to utility ratepayers, to the environment of transportation electrification, which is why there's a strong business case for investment in the charging infrastructure as well, because that is so critical to advance and accelerate widespread transportation electrification. Next slide, please. So we see a very clear need for engagement of utilities, energy regulators, high-level state policymakers, consumer, ratepayer advocates, other stakeholders in the Northeast and the Mid-Atlantic states on the benefits of ratepayer investment in transportation electrification programs. So the effort to launch a utility engagement initiative in the Northeast and the Mid-Atlantic states is definitely going to be a major focus of our efforts over the next several years. Next slide, please. So on consumer outreach and education, as I said, consumer acceptance of this technology is the key. Unfortunately, all of the surveys and other research that's been done are telling us that consumers simply aren't aware of the technology, or if they are, they don't really understand it. And they're not really giving serious consideration to electric vehicles as a transportation option. So there's a big problem, given that the success of this whole ZEV program ultimately depends on consumer acceptance. So this is not a problem that's unique to the United States. In the United Kingdom, which also has a national vehicle incentive program, a very good one, in fact, they're experiencing the same challenges. And several years ago, the United Kingdom launched a campaign called Go Ultra Low, It was a joint national government industry-funded multimedia campaign to raise consumer awareness and interest. And you can see from the metrics on this slide, which I'm not going to repeat, but you can see that they've been really successful. They've increased uptake in their grant program significantly just in 1 year, in the first year after the awareness program was launched. So it's been a really successful program, and we would like to take a page from their book in this country and do something similar to that. So we have the ZEV-MAU states, the task force, have proposed a multimedia collaborative government auto industry funded consumer awareness campaign that would be loosely modeled on the Go Ultra Low campaign in the United Kingdom. And we are very pleased. The automakers have responded very positively to our proposal. So we are really excited about moving forward with them and to make this initiative happen. So that is going to be the third area where we will be really focusing our efforts and placing a lot of emphasis over the next couple of years. Next slide, please. So I would like to end by talking a little bit about two other factors that are a bit outside of our control as states, but I think promise to be game changers in the Northeast market in particular. The first is regulatory. It's called the travel provision, and this is not something that is well known to folks who are not working closely with the ZEV mandate or the ZEV regulation. The travel provision has been in place as part of the California ZEV program since the early years. And basically what it does is it gives automakers credit under the regulation in all other ZEV states for cars that are placed in California. So they get credit for placing cars in California only, even though they have not placed. They get credit for placing cars in California without having to place any cars in the other Section 177 states. So the purpose of this travel provision, it was intended to allow automakers in the early years of the program, when the technology was developing, to focus their efforts on a single market and in California, and that's basically what has happened. Automakers largely, not all of them, but to a large extent, have focused both their technology development and their marketing efforts on the California market, and as a result, we in the Northeast states have been experiencing very spotty availability is the best way I can describe it. Many models that are widely available in California and sometimes in Oregon on the West Coast are only available in small numbers in our states or not at all. And, one example I will give, and not to single out automakers, but one example I will give is in my home state. General Motors in Maryland has a plant that manufactures the electric drivetrain for the Chevy Spark. And we could not buy the Chevy Spark in Maryland until last year. It just was not offered, and it's still not offered in any other Northeast state. So it's just one example, but it gives you an idea of the challenges that we faced. So this travel provision expires at the end of the 2017 model year, and at that point, automakers will no longer get credit in other states for cars placed only in California. So they will have to begin placing cars in our states to achieve compliance with the regulatory requirements. So you can see on the chart that's on the right-hand side of this slide that the sales requirements in the 177 states really start ramping up in model year 2018. And, we expect to see as a result of that an increase in the diversity of models and the number of available models, starting with that model year. And we think that is definitely going to lead to increased sales in the Northeast states. Next slide, please. And the second development or factor that is going to be a game changer is the technology development. In 2012, the Nissan Leaf was on the cutting edge of the technology with electric range of 84 miles. It is really amazing that in just 5 years, the range of affordable battery electric vehicles will have more than doubled without large increases in price. So both the Chevy Bolt and the Tesla Model 3 will have 200-mile plus ranges, and they will be introduced in production in model year 2017, although many think that the Model 3 won't be coming out until 2018. But that 200-mile range is going to be more than adequate for the daily needs of most consumers, and particularly Northeast consumers who lose some battery range as a result of the cold weather during cold months. So, with the federal tax credit plus the state rebates and the tax credit, these cars with these much longer ranges are now very competitive price-wise with conventionally fueled vehicles. So I think we may be reaching the tipping point with mainstream consumers that we've been sort of working toward for all these years. And I think, the fact that there were more than 400,000 pre-production orders for the Tesla Model 3 is a really optimistic sign. I mean, that response was, I think, beyond anyone's expectations. So we are very optimistic about the future for electrification in the Northeast states. And I will end my presentation on that note and take questions.
Thanks so much, Kathy. We have a couple of questions from the audience that has come in. If people have questions, you can use the chat function to submit. One question we got was on this issue of the environmental outcome from electric vehicles. Obviously, they don't have tailpipe emissions, so that's good. But to generate electricity can produce pollution. So do you know how those things balance out? If on balance, on a life cycle basis, we're better off with electric vehicles? Have you all looked into that?
Well, there's a lot of work that has been done on that. And yes, on the whole, we are definitely better off. The environmental benefits clearly depend on the generation portfolio in the area where the electricity is being generated. So in the Northeast, for example, we have been very successful in greening our grid in other areas of the country, and so benefits are greatest there, obviously lesser in states which are largely coal-fired, but still on the whole an overall benefit. And I think the exciting thing is that there's clearly a lot of work going on right now to green the grid. A lot of market forces are having an impact on the emissions portfolio of our power sector across the country. And so I think we can look forward to increasing renewable integration across the country and lower emissions, and that all translates into much greater environmental benefits for electric vehicles. So as we green the grid, we continually reduce emissions from the transportation sector and electrified transportation sector.
Great, thanks. Another question, this is from me. So you're part of a group of states that are doing a lot on the policy front to advance electric vehicles. What do you think more could be done at the federal level, the state and local level? Particularly for the quadrennial energy review, we'd be interested in federal policy options because that's something that we'll be looking into, but we're also interested, and I think many of our audience would be interested in what other kind of policy measures are possible at all levels beyond what you all are doing or what you recommend other regions adopt that you're already doing.
So, sure. So on the federal side of things, a couple of things, focusing first on federal incentives. The federal tax credit, the existing federal tax credit for vehicles is likely going to start expiring for a number of automakers in the next couple of years. GM Bolt and Nissan Leaf market penetrations are reaching the cap, Tesla as well. And, we saw with the expiration of the Georgia incentive program, and this was a repeal of the Georgia tax incentive, very good, very generous incentive program, which once the repeal took effect, resulted in a 90% reduction in the sale of electric vehicles in the Atlanta market. So we saw with that how important purchase incentives, are for this early market development. And so I think it's really important. It's not too early to start thinking about extending the federal tax incentive program for all automakers. I don't think that we've reached the point where we no longer need incentives. And the other, I think, very important aspect of a federal incentive program, we know from experience now that point-of-sale rebates are much more effective and more equitable in terms of incentives than tax credits, which some people simply can't take full advantage of because they don't have the tax liability. And you don't get a reduction. It's not money on the hood kind of reduction that really reduces the purchase price up front for consumers. So I would say that is really important to start looking at. I think that the hydrogen fuel cell credit expires at the end of this year. I think that some consideration should be given to extending that federal tax credit as well. I think it's important for us to ensure that our federal greenhouse gas and CAFE standards through model year 2025 aren't weakened, and that those standards actually are strengthened in post-2025 to take into account the technology advances that we're beginning to see now. And, I think I'm just going to note this, but the Federal Highway Administration has just asked for comment in a notice of proposed rulemaking on the use of CO2 as a national performance management measure under MAP 21. So they're basically asking whether we should be tracking CO2 emissions as a planning and reporting tool. NASSCOM, our states are considering whether or not to submit comments on this, and I don't know what the position on the proposed rulemaking would be, but I would say that it would be a very significant policy initiative that would introduce GHG emissions planning and reporting at least into some aspects of transportation planning process, which I think is significant. I also think that the federal government could be very helpful in leading the way in developing a new model to generate highway funding that is fair to all drivers and doesn't wind up acting as a disincentive to widespread adoption of zero-emission vehicles and fuel-efficient vehicles for that matter, because otherwise we're going to see more states starting to establish additional user fees for zero-emission vehicles, as Georgia and several other states have done. And right now, I think that's probably counterproductive. User fees will act as a disincentive for consumers who might otherwise consider purchasing an electric vehicle. So that's something I think the federal government might be able to demonstrate some leadership on. I guess the last major federal recommendation or request, really in the form of a request, I think that, we're working in the states on a lot of different consumer outreach and education efforts, right in addition to the collaborative industry effort we're working on. All of our states have Ride and Drive and efforts and websites, and we're all doing a wide range of initiatives, implementing a wide range of initiatives to generate consumer interest. But I think that what we really need is a federally funded, very broad-based, multimedia national consumer outreach and education campaign. To build on the current efforts. DOE is doing a great job. The EV Everywhere program is working on a sort of a grassroots outreach effort, but I think we need to build on that and build on what the states and the advocacy organizations are doing. And I just don't think we can do too much consumer outreach and education. I think it would be very helpful to have the federal government, the funding and the voice of the federal government behind such an effort. So those are the I think probably some of the biggest federal initiatives that I think could help accelerate transportation electrification at the federal level.
Thank you so much.
Go on and talk about state, or save that for later?
Well, we're actually out of time, although maybe 1 minute. Can you do 1 minute on states?
Yep, I sure can. So on the state side, I'm just going to say a couple things. I think really important on the state side is for states to have a very clearly articulated state vision for electrification of the transportation sector. I think it's really important to send a strong signal to industry, to utilities, to other state policymakers. So I think that's really important. I think establishment of zero emission vehicle goals and targets, both for public fleets and for state transportation sectors as a whole, is really important. Regulatory requirements drive progress. And the ZEV regulation is largely responsible for the technology that we have today in this country. And then the last sort of high-level recommendation I would have, in addition to all of the various things that I've talked about today and that we're doing, is establishment of a collaborative stakeholder organization. A lot of the states, California has an organization called the PEV Collaborative, Maryland has the Electric Vehicle Infrastructure Council, Massachusetts has a ZEV Commission. I think collaborative stakeholder organizations are really effective in helping to steer a path forward for states and to sort of address in a collaborative way the many challenges that need to be addressed as we move toward electrification. So those are 3 high-level recommendations.
That's great. Thank you so much, Kathy, and thank you to our audience members for submitting questions. Because we are short on time, we're going to request if people have additional questions, please send them in to us, and we will make sure that we get them to Kathy and she can follow up so that we can all get our questions answered. We really appreciate the presentation and the audience participation. So shifting to our next presentation, which will feature Mike McDonald, Senior Engineer at American Water, and he's going to talk about energy efficiency opportunities in the water sector. So take it away, Mike.
Thank you, Judy and Terry. Thank you for all the great work you're doing and your organizations are doing in this space. We really appreciate it. Thank you, Kathy, for sharing such an interesting and fascinating topic. So we're pleased to have this opportunity to share some of our experiences in the water industry and water industry experiences and ideas with respect to energy in our space. So I'm going to start out with a little introduction and discussion on where energy is used, how it's used, and where it's potentially lost in water systems. And then we'll follow up with some policy ideas. Next slide, please. So American Water is the largest investor-owned water utility in the country. We operate in just about all of the states except maybe for 9 or 10 or so. We serve 1,500 communities and we deliver about 1 billion gallons of water a day. We like to think that we represent somewhat of a microcosm of the water industry across the country in general due to this geographical diversity. Next, please. So this slide illustrates very simplistically what the connection is between water and energy. It takes a lot of energy to make water, and it takes a lot of water to make energy. The other commonalities that we share with the electric industry is that we're both critical resources to the public, and for that reason we're critical to each other. And there's a high level of dependency and resiliency on each other. So it's important that we maintain our resiliency, and it's equally important that the electric utilities maintain their resiliency for both of us to be sustainable. And this plays into the Accelerate Energy Productivity Roadmap, developed in September 2015, where you can see water infrastructure is one of the 6 wedges that's been identified. Next, please. So a couple of facts. It takes about 13 gallons of water to produce a gallon of gasoline, so there are some supply chain ramifications to water and energy. Shale gas, we have a shale gas unit here at American Water, and what we're seeing is that it takes about 3 to 7 million gallons of water per frac. And that's pretty consistent with what we're hearing in the industry as well. This does vary across the country. These are for the Utica and Marcellus formations, which are here on the East Coast. Some of the formations in South Dakota and Texas may vary considerably. And to underscore the interdependency that was mentioned in the previous page, thermoelectric power plants withdraw a lot of water, about 200 billion gallons a day, and roughly 40% of all the fresh water that's withdrawn. So that really illustrates that interdependency. And the flip side of that coin is water treatment utilizes about 4% of the overall energy that's used nationwide for the treatment, storage, movement, and delivery of water. Next, please. So this is a very simplistic slide trying to draw correlations between the 2 industries because I think it is significant when it comes to policy ramifications. So if we focus on the 3 illustrations on the left, we have an electric wire and a water pipe. So it takes voltage to push the fluid, to push electrons through a conduit or through wire. Similarly, it takes pressure to push the flow of water through a pipe. And that pressure comes from pumps, which we'll see in a minute, take up 80 to 90% of the overall energy use in the water industry, which is why I wanted to show this illustration. It takes a lot of energy to push that water through the pipe. Both industries also have a resistance component in their transmission and distribution. And the resistance in the water industry is a function of pipe size, but also old and deteriorating infrastructure. So if you look on the right-hand side there, you can see a pipe that's been removed from the ground. And this is not atypical. We're seeing a lot of 100-plus-year-old pipe in the ground. And when you pull that pipe out, you can see how that diameter has decreased substantially. So the resistance in that pipe, and therefore the energy needed to push the water through that pipe, increases substantially. This is important because it illustrates the strong linkage between what our industry is facing with old and deteriorating infrastructure and the linkage to energy and how it impacts energy use. Next, please. So as mentioned earlier, 80 to 90% of the energy is from pumping. The illustration on the left shows a variety of areas within a typical water distribution system where pumping is utilized. Pumping is first used to pump water from the source, and that could be groundwater, it could be an ocean and desalination, or more commonly, it could be a reservoir of fresh water. That gets pumped to the treatment plant. There's some minor pumping that takes place in the treatment plant, and then the biggest energy use is pumping from the treatment plant and into the system, and that's labeled as treated water to system here. Then once it gets out into the system, it's boosted around the system. What we're seeing is typically about 2,000 kilowatt hours per million gallons is it's about what we're seeing here at American Water, and it corroborates with some research that's been done, shown on the right here. The third bar over is the U.S. average. It's about 2,000 kilowatt hours per million gallons there for water energy intensity. And you can see there are some outliers. California is much higher than that, and that's because they literally have to pump water around the state. And again, that's where the pumping and the energy comes into play. Next, please. So this is just a quick illustration to bring home at a more fundamental level what the heaviness of water. So it takes a lot of energy, basically because water is heavy. We deliver 1 ton of water every day to each customer. Next, please. So where does the energy get lost, and where can we make some progress with increasing energy efficiency in water systems? Again, coming back to that theme, pumps. It's 80 to 90% of the energy used. The average efficiency of a pump is about 55%, a pump and a motor combination. Wire to water is a means for measuring that efficiency. So clearly, by reducing energy and replacing or rehabilitating these inefficient pumps and motors, we can increase that number. And what we'd like to see in more of an ideal situation is about 80%. The graph or the illustration in the bottom right-hand corner is where the industry is headed, where American Water is headed, and that's with tying in the usage in real time so that we can bring some value directly down to the operator level. So in this particular illustration, you can see there are 4 pumps in this pump station. There's some data there that the operator can look at. Now, granted, this is not the most user-friendly slide or interface, and this is what we're working on, is how to make it more user-friendly with operators. But we feel if we can get real-time information in front of operators like this, we can see some substantial savings by letting them have a role in which pumps to operate, when to operate them, so that we can cut back on peak demands and just basically have much more flexibility and empowerment with that. And again, this is an area where the industry is headed, instrumentation and controls in general. Next, please. Another area where energy is lost in the water system is through leaking mains. Again, coming back to a common theme of deteriorating infrastructure, old pipes in the ground. The United States loses about 6 billion gallons of treated water every day due to leaks in the systems. Roughly, the industry average is roughly somewhere between 18 and 20% of all water is lost in pipes. So there are a couple of areas where energy can be saved if leaking is stopped. If leaking is stopped, you simply pump less water at the distribution plant and all that pumping. And if you pump less water, you use less energy. And also, if you decrease the overall, if we can decrease the overall system pressure, then that applies less pressure literally to the piping systems, these old piping systems, which mitigates and reduces the number of leaks in the system. The third advantage of this is that oftentimes the systems have a lot of pressure in them, too much pressure. And all that energy is just simply lost when a customer or consumer turns on their tap. So there are a couple areas in the distribution itself where energy can be saved, and this is often lost in the conversation on water efficiency in the water industry, primarily because the 80 to 90% from the pumps is such a big headline number. But the connection between us needing to replace this old infrastructure and the energy savings that can be incurred is significant. Next, please. So energy is also lost through inefficient appliances. We've had some very successful programs that have helped reduce water and thus reduce energy over the past, well, 94 is when the water efficiency movement started, so roughly 20 years or so. We saved 1 trillion gallons of water in that time and about $22 billion or so in water and energy bills. So 2006 is the inception of WaterSense. A lot of the water efficiency programs were started around 1994. This EPA WaterSense program has been particularly helpful. The bottom right-hand box shows a percentage decrease per year per customer in residential use, and that's pretty much throughout the industry, 1 to 1.5% per year, and we don't see much of an end to that probably for the next 5 to 10 years. So again, largely to these programs, we've seen some great progress in reducing water use. Next, please. So one area where the water industry is particularly differentiated from the electric industry is that we do have the ability to store water. And by storing water, we implicitly store energy. The other benefit of that is it does allow us some operational flexibility. So getting back to that operator in the room, pushing the buttons and pulling the levers for the pumps, he can have some flexibility when he may turn on a 1,500 horsepower pump or two of those, or operate different systems simultaneously, which helps reduce the peak load. Indeed, this has been a space that the industry has been involved with. One of the companies that helps with that is Enbala Power Networks. And we've engaged them in one of our facilities in Pennsylvania, and we've had good luck with it. It's pretty much under the radar, and it saves the energy utility with peak load demand as well. So we hope to make further progress in this space. Next, please. And then we have alternative energy. The take home here is that American Water, anyway, we uses a lot of energy. Okay, the industry in general uses a lot of energy, but American Water also has a lot of land. So we operate in all those states that are shown in that first map. So these are the two ingredients for solar applications. We have made some headway in this area as well. The photo down in the bottom is an example of what we're calling photovoltaics. So photovoltaics that are floating on the water. This is something unique to what we've done, and I think what the water industry has done. And they rise and fall with the reservoir level. They have the added benefit of reducing reservoir evaporation and also reducing algae growth. One of our endeavors here is to incorporate energy use and energy efficiency into our overall planning process. So our planning process frequently, every 5 years or so, visits one of our many systems out in the country and assesses the older infrastructure, assesses process requirements and everything to do with what we need to do to deliver a safe and reliable water supply. And we've recently started including energy in that. So we're looking at energy efficiency, we're looking at demand usage, we are coordinating much more with energy utilities. And the upper right illustration shows a couple of solar panels or photovoltaic fields that are being used in areas of old structures that have been demolished. So what we're proposing there is that we repurpose that space for solar power. And this is something that we are taking seriously here and incorporating in all of our studies. Next, please. So then we get into the area of new and emerging technologies. The geothermal heating and cooling is something that American Water is proud of. We have a facility in New York that we've piloted. This pilot study is basically the same as your standard geothermal heating and cooling, except rather than pulling water from groundwater wells, we're using the pipe in our pipes. We're using the water in our pipes, so that water acclimates to whatever the temperature is in the ground, and then we utilize the embedded energy similarly to the more conventional geothermal heating and cooling. Irrigation has some potential as well. There's a lot of neat and new technology out there. What's shown here is a photo of a smart controller, and that can be controlled based on soil moisture. It can be controlled based on web-based weather data. It can be run remotely. And we've made a lot of headway with internal appliance conservation. And this is probably the next frontier, if you would, with consumer awareness and conservation at that level. It's also more elastic than internal use. There's more discretion with how it's being used. So we're pretty optimistic with some of the advances we can make here. Next, please. So let's talk about wastewater for a slide at least. Wastewater has a lot of potential. Frankly, it has equal or more potential than water treatment plants. That's because there's a lot of embedded energy in wastewater in the form of carbon and temperature. So we try to take advantage of that at the wastewater facilities that we do own and or operate. American Water has patented a technology that reduces aeration energy by up to 50%. Wastewater reuse industry-wide is very big now. We have a facility up in New York where we utilize wastewater reuse for toilet flushing, cooling tower water, and irrigation. Energy recovery industry-wide is clearly the biggest opportunity for a wastewater facility, and that generally, not generally, but it does come from anaerobic digestion, which emits methane, and that methane can in turn be used as fuel. If augmented and done correctly in other areas, that can help drive a facility towards net zero energy, and that has been done at a handful of facilities across the country. Some of those augmentation areas might be alternative energy to help supply energy to the overall facility. Co-digestion, fats, oil, and grease are a common one, and this is something that's getting a lot more attention. Basically, taking the fats, oil, and grease from restaurants or whatever it might be around the area and utilizing that for co-digestion, basically increasing the carbon source and thereby increasing the emissions of methane. And combined heat and power increases the overall efficiency, and of course financing cannot be overlooked and probably should be first here. That always is it comes down to the ultimate determination. And heat recovery from the raw and or treated water as well. Next, please. So hopefully, having provided some context, I'd like to talk a little bit about policy considerations, policies that are in place now, what we have found here, what the industry has found is helpful, would be helpful, and could be helpful for advancing energy efficiency in the water wastewater industry. Next, please. We've had some great successes in energy savings industry-wide and here at American Water. The elephant in the room is the deteriorating infrastructure costs that the water industry in general faces, and the resiliency aspect in the face of climate variability as well. So we strive, but we also have an operational efficiency goal. So we strive for energy efficiency. We do find there's some competition for those dollars when it comes down to an energy efficiency project or a project that's needed to deliver a safe and reliable water supply. There is some back and forth and some real scrutiny into which project is most needed at that time. The other area is because we have been so successful in reducing water sales, we are in turn reducing our revenue. And that revenue is utilized for our fixed costs. So there's a challenge with our rate structure as well. Next slide, please. So I've highlighted 4 bullets here. The 4th one is on the next slide. Just going after the largest energy users first. What has helped us tremendously in replacing motors and pumps and upgrading them to be more efficient is the rebates that we get both federally and from the electric utilities. What we do here at American Water is we essentially look at what the payback is given the cost of electricity in a certain state, given the size of the pump, how much it's going to cost to replace it, and a variety of other factors. And then we determine whether or not it fits into our, I'll call it our bucket of potential candidates for renewal. So to the extent that we can increase that opportunity or increase that bucket size by making these replacements more cost effective, that's where these rebates and policy incentives are incredibly helpful. The second bullet is the instrumentation and control technology, which I had referenced earlier. The industry, the water industry in general, is headed this way. American Water is headed this way. It seems simple, and it is, and it has great repercussions in terms of saving energy. So in terms of policy ramifications, to the extent that electric utilities and or policymakers can acknowledge that this is yet another technology. It's not just putting instrumentation and controls on our systems. It will actually help save energy. So that communication and dialogue, looking at this as indeed another technology, I think would help progress that conversation. The second bullet is alternative energy as related to resiliency. I should have stressed this in the earlier slide, but I didn't. Resiliency has come up here as an important reminder to me that alternative energy and backup power supplies not only provide energy efficiency to the water industry, but because we are 24/7 and we have to supply water, we also need to remain resilient. So backup power and alternative energy is priceless with what we need to do. So SRECs and credits and all of the other incentives that are out there to help us get there are helpful and will continue to be helpful. And again, the portfolio diversification of energy and fuel helps increase our efficiency as well as our resiliency. The third bullet discusses a little bit about the collaboration between utilities. The progress we've made with load shifting has been good. There's still room for continued progress there. So that sort of collaboration is important. Time of day use in particular. Leveraging new technologies, of course, is always something we want to keep on the front burner. Improve synchronization of water and energy efficiency programs. What I mean with this bullet is that we have a lot of potential, I think, to save energy in the water industry, and there's only a handful of folks in the water industry that have a handle on the incentives that are being offered by the electric utilities. So part of it is education, awareness, sitting down right at the operator level, up through engineering and then up through management on where we can actually collaborate with utilities on our common goal of working with old infrastructure and saving energy, and the energy utilities goal of saving energy. So a handful of us know the pressure and understand the pressure that the electric utilities are under to meet some of their goals, and we're willing to help. And we're fairly old industry that's been filling tanks for the last 100 years. This is all relatively new to us, so to the extent that we can have some guidance or dialogue or increase that conversation, that would be helpful. And the last bullet here is we were noted in the Clean Power Plan for efficiency gains in the water wastewater industry. Next slide. And then finally, water efficiency. We've made amazing progress with low-flow toilets, appliances, shower heads, washers, and dishwashers. The alternative rate mechanisms are important. Right now, they do not encourage water efficiency. So if we can have an open dialogue on how we can look at these rate mechanisms and efficiency, that will go a long way. Optimize and reduce customer irrigation, that was mentioned earlier as a new and emerging technology. Demand-side management programs where we actually get out there and talk with the public, and we help finance some of the software and that goes into that. If that's similar to capital projects, that would add further incentive to working with our customers for energy conservation. And then the last point here is pipe replacement is a big issue within the water industry in general, because it is just so old and it needs to be replaced at an accelerated pace. It also saves energy. So there is a strong linkage there between what we need to do and what the electric industry needs to do. So that's it for me. I'd be happy to take some questions, and I thank you for your time.
Thanks so much. We're close to out of time, but let's see if we can do one quick one. We got a question from an audience member on advanced water metering. Is there an interesting thing happening in advanced water metering, like ideas to help that happen if it matters? Can you say anything about that?
Yes, we are making a lot of progress with advanced water metering too, and that plays into the water loss component of the presentation. Basically, by metering more effectively and more accurately, we can track our water use better and our water loss better. So we've got, and I think the industry in general does as well, but we've got a large program underway right now to roll out advanced water metering, AMI, throughout most of our systems in the U.S.
And I guess I'll give one more, since you were so nice and fast on that one more quick. Any sort of like final thoughts for us as we're looking into the quadrennial energy review of particular things we should either recommend or at least consider on the federal policy front?
Well, yeah, I think the rate structure that we're operating under right now would go a long way to revisit. Right now, we're not being encouraged to save water. We're doing what's right at this point, and we're doing what's right for the environment and passing flows and everything we should be doing. But we do need to be a sustainable business at the same time. So I think any sort of policy that would help a revisit of rates would be helpful. Batteries and storage, it's not our field, but it sure would help, because we are 24/7. We can utilize the alternative energy, but it's only as good as when the sun shines or when the wind blows. And maintaining the incentives for green energy has been critical. Even with the rapid drop-off in solar prices, installation and panel prices, it still helps get us across the line in most of our states. So I think those three areas come to mind.
Well, that's great. Thank you so much to both you, Mike, and to Kathy for the excellent presentations, and thanks so much to the audience for your great questions. And once again, if you do have questions that we didn't get a chance to answer, please do submit them, and we will submit them to the speakers and get back to you and make sure that all of your questions are answered. Also, we're going to have the presentations available to be downloaded in the GoToMeeting chat window, and will also be posted to the website at energy2030.org. If your organization is interested in taking a more proactive role in the Accelerate Energy Productivity 2030 initiative, we welcome you to join the 136 other organizations that have pledged to improve their energy productivity. And again, you do that on our website. The key takeaways from this webinar series, this one as well as the other two, will be synthesized and will help inform the recommendations made in the upcoming QER. So we really appreciate your participation, would love continued engagement, and please, we do indeed welcome your input. And thank you again for participating, and thanks once again to our partners at the Council on Competitiveness and Alliance to Save Energy. This has been and continues to be a wonderful partnership between DOE and our partners on Accelerate Energy Productivity 2030. Thank you.